how global this community is. Yes. Oh, nice. I see people joining from India. Uh-huh. Yeah, Nigeria. Good. So, and if you feel like it, you can also share how you're feeling today. Excited, curious, or simply happy to be here. We'll get started in about 2 or 3 minutes. I'm looking forward to starting together very soon. Nigeria Lagos. Mhm. Oh, parking. Oh, Cameroon. Oh, nice. Cameroon, so far. So far. What time is Cameroon? What time in Cameroon? Oh, nice. Oh, good. Afternoon. Mm-hmm. Good time. Good time. Okay. Thank you, sharing. All right, thank you for waiting. Let's begin. So before we move into today's sessions, I'd just like to share a few words. First of all, thank you so much for being here. I'm really happy that we can spend this time together. So, and to our speakers, thank you for being here and for sharing your time and experience with us. So we have a wonderful lineup today with a variety of backgrounds and perspectives. So I'm really looking forward to each session. Even a small idea can make a difference. I hope today bring you something meaningful, maybe a bit inspiration, curiosity, or even a new connection. So, and please feel free to joining the conversation, say hello, share your thoughts, or drop your links in the chat. Let's keep this space warm and open. So, and now I'd like to start with a short opening talk from myself. Thank you. So, next, just a quick introduction. So, I started this community to connect the people not only through AWS, but beyond that. So, now I co-organize this community with Yuki, who helps support and grow this space together with me. So if you'd like to get involved, please feel free to reach out anytime. We'd really love to connect it with you. So, today's schedule. Uh, Now let me introduce today's speakers. So we have five wonderful speakers joining us today. Sis, Shabir, Sharti, Handler, and Blauscher. So some of them are returning speakers and some are joining us for the first time. I'm really excited to have this mix with us today. So they are joining from different countries and time zones again. So which really shows how global this community is. So we'll follow the order shown on this slide, but it may change slightly depending on the situation. Each session will be around 15 minutes. So after each session, I'll share a short comment or question, and we'd love to hear from you as well. Please feel free to use the chat anytime. And before we continue, just a quick note. You can join this meetup on Zoom or YouTube, whichever works best for you. So feel free to share your thoughts on X using the hashtag AWS Global Community or in the Zoom chat anytime. So you are welcome to jump into the conversation anytime. So just during the sessions, please keep your mic mute. And most importantly, please be respectful and kind to one another. So let's keep this space safe, warm, and welcoming for everyone. And how many of you are joining us for the first time today? And if you will be here before, welcome back. So for those of you who have heard this before, thank you for hearing it again. Oh, first time, thank you so much. So I always like to share this because it's important to us. So this is place where people from all over the world can come together, learn and grow. So it's not about right or wrong answers, right? So what matters is what you notice, what you feel, and the connections you make. So AWS is our starting point, but the real focus is people. So we also welcome first-time speakers. This is a safe and friendly place to share. So before we wrap up this part, we're looking for speakers. Sorry. So quick look at what coming next. Please save the dates for our upcoming meetups. May 22, so 2022, and June 19 and July 24. So we host this meetup every month, and I really hope to see you again. So, and we are always looking for speakers for upcoming sessions. Uh, whether it's your first time or you've spoken many times before, you are all very welcome. So if you are interested, please feel free to send me a DM, direct mail, direct message. So anytime, I'd really love to hear from you. And just to say it again, if you are interested, please feel free to send me a message anytime. I'd really love to hear from you again, again. So we host this meetup at the end of every month. So I hope this won't be just one-time connection. Please scan the QR code to stay connected and check out our upcoming every events. So, and I truly hope to see you again next month. Maybe not just as a participant, but as someone who share as well, let's keep this going together. So, let's keep building this community together. Okay, all right, let's get started. Please join me in welcoming our first speaker, Ashish. Whenever you're ready.
You cannot start sharing while the other participant is sharing. So you have to give me you have to stop sharing, I think, or you have to give me the permission.
Okay.
Perfect.
I'm sharing.
Yep. Now you can see my screen, everyone.
Good.
Okay, perfect.
Perfect.
Okay, perfect. Thanks, Rumi. Hello, everyone. Good morning, good evening, good afternoon to the different time zone people. I'm Ashish Sharma. I'm based out of India, Delhi. I'm working as a solution architect, mainly in the AWS world, and I'm working with Sun Life Global Solution India office, which is you can say a company in India, a GCC in India. The parent is Sun Life Canada. I'm part of the AWS Community Builder. Uh, and today I'm going to present the topic, which is AWS Bedrock Agent Core. 15 minutes is not enough for this topic, but yes, I'll try to wrap up as much as possible in those 15 minutes. So, what is AWS Bedrock Agent Core? So AWS has launched last year, I think, on the second half of the year. AWS has launched a platform, an agentic platform, which is going to be helping us in building and deploying agents effectively, securely, and at scale. What does it mean in terms of effectively and at scale, you can say? So it's not like you create your agent using a LangGraph or a LangChain and now deploying it to the Lambda and then using it. Or after that, you have to do all the operations related to that in there, because the Lambda is having you can say very good features, but yeah, some limitations as well. So if you are going to deploy in Lambda, all the limitations of that Lambda is also going to be with you. Similarly, if you want to deploy it as an ECS, as an EC2, the entire thing, which is of good features of those services, is going to be part of your agent, but all the drawbacks, or you can say all the limitations of those services, also going to be the part of your agent package. So what AWS has come up with, they have come up with a different agentic platform, or you can say platform for the agents, which is Agent Core, and it has multiple components in there. So if you see in the diagram, the agent, if you want to deploy your agent, there is a thing called runtime, in which your tools and your agents is going to be deployed. Uh, there is a thing called registry as well. So registry is pretty new. I think you guys are part of the AWS community builder. You know, in last few months only, there were so many sessions happened for the registry, and now registry is out for the public. So registry is basically, you can say, you can register all your agents, your MCP tools, your servers, everything in there, so that in your enterprise, in your organization, everything is can be centralized, managed in there. So that is for registries for. Then there is a thing called policy. Policy is for the authorization control. What your agent can perform, you can control it through the policy. And policy, you can use it as a CEDAR policy, or you can use it as a natural language policy as well, which gets converted into the CEDAR in there. They have a memory as well, like for any agent. Memory is also very important part. So they have an inbuilt capability in agent core itself, which is a memory. So what is good thing about that is now we have a short term and a long term memory concept. So now if there are two different invocation of the agents, and suppose both are sharing the same memory, so in terms of the context it is going to stored, it is going to be not just stored but can be shared between the two agents as well. There is an identity. Identity is for both the inbound and outbound authentication. What does it mean is how you want to connect to the agent, and how your agent is going to connect to the different services in the back end. So that is the inbound and the outbound authentication. That comes under identity.
You don't need to give that space, just give that okay.
Guys, can you put yourself on mute? Okay. Uh, There's a thing called gateway. I'll come to that gateway later. Then there is a built-in tool as well, which is basically different built-in tools which is there as browser, as code interpreter, as knowledge base, as search. So what does built-in tools means is if your agent wants to perform some actions using code interpreter, using browser, so you don't have to build that functionality within your agents. The built-in tool can be used by your agents. Then there is an
Sensei,
eval. Yep.
I can use share screen.
Sorry.
I can your slide. Please again. Can you share your screen?
I will do that again. No worries.
Yes.
Can you see my screen now?
Now it's okay. Good. Very good. Thank
Okay,
you.
perfect. There is an observability, which is it's pretty standard for the monitoring and debugging. And I'm saying it is standard, but it has good feature in terms of finding out each instance of your agent run, where it is performing, what it is performing, in terms of all the services which has been used, which has been all the policy that has been exposed or used, which has approved, which has denied, or each and every instance is there in the observability. It is supported by the CloudWatch. Then we have evaluation, which is basically a batch evaluator, online evaluation configuration, and custom evaluator. This is to evaluate the agent that you can write your custom evaluators as well to evaluate the agents. Now I can come. Now I want to come back to gateway, and I have left it back because I personally like gateway very much. So gateway is basically a gateway for your agent to interact with other services. So I'll give an example. Suppose, like couple of years ago, the agents was not there. All we were writing is APIs. Now you have so many APIs in your application, in your organization. Now with the agentic word comes in, what is the use of those APIs in there? So the one way is you start rewriting everything. When you are going to restart rewriting everything, the application which is consuming those API is going to be changed as well. So what is going to happen with this gateway is you don't have to change any of your API. And when I'm saying any of API, I'm saying zero line of code changes is required to your API. No deployment, nothing. Whatever you have already deployed, already placed the API in whichever environment, it is going to be like that only. All you have to do is you have to expose using the agent core gateway those APIs with proper authentication authorizations to the agent core or agent core runtime, that the agent which is there. So what is going to happen is when your agent want to perform any operations which is already written or already available under some API, the agent can use those APIs through the gateway. That's why I like about this, that all the existing thing which is there, for example your APIs, your lambda functions, which is already there in your application, in your organization, that is not something which is of no use now. That can be used interacting with any of your agent with the proper gateway in place in there, with authorization and other. This slide is talking about the same thing which I have already talked about, like runtime for agent and tool. Runtime offers a secure serverless purpose-built way to deploy and scale your AI agents. That is there. And one more thing is pretty much is it is not dependent on one framework. So when I'm saying is like you can use LangGraph, you can use LangChain, you want to use strand agents, you can use anything which you want to use, any framework which you want to use to write the code for your agents. It's not dependent on one framework that okay, it is an AWS agnostic and now it is going to be you. The strands agents is the only thing which is going to be used. Yes, definitely everything is having a pros and cons, but in terms of the choosing the framework, it is giving you the liberty to choose the framework. Memory, as I talked about the long term and short term memory, it is same. So it is pretty much the same. So I'm going to skip this thing and come back on each component in there quickly. So this is the runtime. So how the runtime is going to work is you are going to choose your framework which you want to choose. For example, you want to choose LangGraph, or you want to choose any model that you want to choose. So it's not also a thing which is dependent on AWS Bedrock for choosing the LLM. You can choose the OpenAI, the Claude, the anything Crew AI. That is anything you want to choose. You can choose it. API is all you require is an API key or the way to authenticate it, and it will work. So your framework which you have chosen, your model which you have chosen, all you have to do is the couple of line of code changes, which is agent core runtime decorators, like at the rate app entry, something like that. Some decorators you need to place to make it available or to make it ready for the deployment on the agent core. That you can do. You have to put in the identity if you want to put the observability configs. All you can do is, and then there's some commands which is like, for example, agent core configure command is there. So it is going to do is it will ask you a couple of things in terms of what is the name of your agents, what is the memory of your agent. So all those basic question it is going to ask, and then it will create a Docker file for you. And the second command is agent core launch. So when you are going to launch the agent core, so it is going to use code build ECR repositories and then deploy the agents to your runtime agent, and also provide you an endpoint, or you can say an entry point in there. All this code build ECR repository, you don't have to, I would say, put in place. But yes, it's better because now if you are in an enterprise going to deploy so many agents, so it's better to manage those things as well, so that you have that, okay, ECR repositories and code builds, everything pretty much managed, rather than randomly agent core is picking up and managing for you. And yes, your agent is now ready in the agent code run. Just want to play around with that, you can go in the AWS Bedrock Agent Core console, and there is an option of test the agent as well. You can just select your, it will provide you the list of all agents that is deployed. You can select it and give the prompt that you want to give. This is the gateway which I was talking about, that your agent is going to be. So if you see on the right hand side, your API tool resources, which is pretty much existing, which is there. And in the center, you have the gateway. On the left hand side is your agent. So your agent is going to use the APIs, the tool, or any resources which are available using the AWS Bedrock agent core gateway. And it is going to be authenticated, or you can say not authenticated, the authorization is happening using the identity. And for the observability, the CloudWatch is there. So you can place your inbound and outbound uh, authentication method. So it supports multiple methods in there. I'm going to cover that in the AWS Agent Core identity. This is the identity. If you see here, we are talking about the agent, which is going to now interact with the gateway or any other resource of AWS, or even external, how it can do that. So if you can see on the left hand side, there is an inbound authentication. For the inbound authentication, the OAuth2 JWT token will be used for anyone who is going to call the agent, which is hosted on the AWS Amazon Bedrock Agent Core runtime. Then this is the outbound. For the outbound, there are multiple ways of doing that. For example, API keys is one of the thing. For example, your API is exposed and you have an API key, so you can use that as well. You want to use any of the AWS resources, you can use it using the IAM. That way the authentication is going to work. And if anything is behind your, excuse me, anything is behind your gateway, then for those, the API is going to work as well. Like an API key is going to work as well as the AWS IAM is also going to work for that, and the OAuth client is going to work for that as well. So for that, you have multiple option how you want to configure that. And as I mentioned, the backend resources, which is already available, any Lambda, any API, anything else, you don't have to change in there. You have to just give them the endpoints in there and the authentication method, and everything is going to be pretty much created by the agent core only. Then we have a memory. For memory, we have two types of memory in there, which is a short term and a long term memory. Short term memory is pretty much can be like for 7 days, 8 days kind of a thing. And I think long term has a timelines of 365 days in there. So if you can see, if the agent does not have a memory, so it's pretty much for fire and forget kind of a thing, that I'm chatting with you and you are now forgetting once I shut down the system, or once you shut down the system. So that is without memory. And with memory is pretty much I'm interacting with the agent, and now agent is building all the context within the memory. And it could be, it has multiple things of like, you can do the summarization, you can use semantic, you can use personalization in terms of, for example, which language I preferred, which I don't, kind of a thing. So you can build it in your memory, and that can be shared once you comes again, in the second time or third time or fourth time in there. This is the policy. Policy is basically the any enforce or any security controls that you want to place on your AI tools. It gives the protective boundary in there. So it is pretty much the Cedar language which is there, which is very easy to understand as well in terms of the policy. It looks like similar to the IAM policy if you see. Not exactly same, but yes, similar in terms of resource is there, action is there, what is deny, what is allow. So something kind of a similar. Also, there is an option of generating the policy using a natural language. So it's like you're passing what you want to do, and automatically it will create the Cedar policy for you. So it's there. One thing about the policy is, if you're going to place policy in any place in terms of, for example, gateway, for each request the policy is going to be assessed. It's not like, for example, just for one request it is going to assess, and after like it is going to store for next 1 minute or 2 minutes or 5 minutes kind of a thing in caching or somewhere else. No, for each request the policy is going to be evaluated in terms of whether it is some things is allowed or some not, because everything is in the agentic word, it's prompt based. So the understanding of your model, of your LLM, is going to be different in terms of maybe you providing a different prompt, even though you want to achieve the same thing. So the policy is going to be assessed each time for every request that you want to perform using your agent, if a policy is placed on that particular resource. Uh, Almost similar if I talk about. So you create your agent. If you see the workflow, it is going to be like that. The step one is basically creating your agent. So you create your agent, choose any of your framework like Strands, LangGraph, Microsoft AutoGen, Crew AI, anything you want to choose. You can choose your model, anything that you want to choose in terms of model, you can choose that. Then you can choose your integration, for example, the memory you want to choose, the observability you want to choose, or any gateway you want to choose. So that are the things that is going to be there. And then you choose your IAC, the infrastructure as code, how you want to deploy that. It could be using a console as of now, for example, if you're testing by yourself, but for an organization, it should not be like like somebody is hitting it manually through there. It's going to be using, for example, Terraform or from Cloud Development Kit as a CDK. So it's going to perform everything for you. The second thing is deploy. So what is going to happen is, it is going to be first is initiating any deployment. The second is, then after that it is going to be basically deploy in there, and in between all the checks is going to be there. For example, the AWS resources, all the necessary permissions in there. IAM roles needs to be created. Any entry point needs to be created. The file is going to be there. So all those things is going to be checked in there when you are going to run the deployment in there. The third is straightforward, invoke your agent. As I mentioned, you can invoke your agent like this, agent core invoke through your CLI. If you have the access connecting to the AWS account and it is going to be connected, you can connect it using console as well if you want to. But yes, if you have any application which is doing that work instead of CLI, for example, agent core invoke and prompt passing the prompt, you can have it working from there as well. This is maybe overwhelming, but this is one of the application that I have created solely using the agent core, or I would say for almost all the components which is available in agent core except the registry, because registry has launched recently, so I have not like integrated the registry in here. But that is not a big deal in terms of the registry, because it's just a registration of the agents. So I'll start on the right hand side. If you see in the right hand side, there are some external API. So what I have done is, I have first created any external application, you can say, and the entire this agentic application that I have created is by the name of resource manager agent. So what is this resource managers? AWS has so many resources in terms of so many services which is there. So what it does is basically, uh, for example, you want to perform the matrices of any of the resource. You want to see the logs of any of the resource. So these are the things, or any status, for example, how many S3 buckets are there in particular region. So all those things, anything you want to do on those resources. So I have created the external API, and this external API is basically performing few of the operations. So I have picked up three services: S3, Dynamo, and Lambda. So if you see this API, it has only the facility, or you can say the feature of matrices only. API matrices for the S3, API matrix for the Lambda, API matrix for the Dynamo, and a API matrix for the reporting of these three services. So that is, you can say, an application which is external to the agent which is available. There are some direct services which is there, like S3, Lambda, Dynamo, APIs, IAMs, and everything in there. So what I have done is this API, and on the left hand side, I have the agent code that I have deployed. So when I'm using the agent code, I was using the LangChain and the LangGraph both. Uh, I have used both the Bedrock as well in terms of the LLM, and I have used Grok as well for the LLM. And in the runtime, it is going to deploy the agent core entry point, the code, which is my Python code, the LangChain and the LangGraph React orchestration, any local MCP tool. So it provides. So there are two things now in there: any local MCP tool, which is like few of the operations which I want to perform on S3, like fetch me the list of all the S3 buckets. It won't go to the external service because the external service is providing the matrices, not exactly the thing which I want to. So I have exposed all these things of S3, Lambda, and Dynamo in the local MCP only. So that is exposed to this agent only, not any other agent if you want to deploy. Then I have put the memory short term as well in and the long term with some strategies of like semantic summary as well as the user preferences, connecting it with the Bedrock LLM basically. For the policy, I have used the Cedar policy in terms of understanding whether this agent is allowed to perform certain action in that region or not. So I have placed some policy in here in terms of perform the operations in, suppose, US East 1 region only. So if the user is asking to perform anything in AP South or anything else, it won't do that operation. So it's basically denial operation if you are going outside of US East 1 and outside of any of these three services: S3, Lambda, and Dynamo. So I've put in these in the policy. All the observability, it's there as part of the agent core. And this is the gateway basically. So I have exposed these external APIs using this agent core gateway. And if you see, all it want is an open API spec. That's it. It is not changing in the anything in the external API. It is just using the open API specifications and using the agent core. And I have used uh, the all these. If you see different APIs has been exposed or has been authorized using different way. I have used API as well. Credential provider I have not used, but I have used API. I have used Sigfo, and I have used OAuth. So I have used all these three to exposing all these API in there. So yeah, so this is the resource manager that I have built in under the Bedrock Agent Core, and yeah, so I'll go to that link. So it's a big service in that sense. So what I have done is Agent Core. I have divided into three parts. So this is the first part, blog, and it is just not that the theoretical thing which I'm telling you as of now. It is pretty much, you can say, all the codes is there, like how it is going to work. All the codes are there. So in this first part, I have talked about a couple of things only. For example, if you see, the part one is all about runtime only. Part two is all about gateway and identity. And part three of this blog is all about memory, built-in policies, observability, and evaluator. So this is part one in which I'm talking about runtime only. So I'm just deploying the agent to the runtime and using it without, for example, putting policy, identity, gateways, anything in there. So it's all there. uh, you'll find that in the GitHub as well, and the repository in one of the branch, which is part one branch or something like that. Yeah, so this is the branch which contains only the part one thing. Similarly, for the part two, I have covered this in the part two, which is uh, gateway and identity. So because it's a big thing, so gateway and identity, and it is the same agent which I was talk about, like the resource manager, which I've talked about. So all these things are there in here related to the gateway and the identity. And then we have the part three. Part three is this coming all the things together in terms of all the things which I've shown you: external APIs, policies, identity, agent core, runtime, gateways, observability, everything come together, and creating all, or you can say using all the agent core capabilities and finding it there. So these are the things which, for example, if you see, these are the things which you'll see in the observability, like how the agent core invokes, it performs operation, what is the different model. For that model, I've used the Cloud 3 Sonnet. So which model it has created, how it goes. So all these flows is going to be there in terms of observability. Different policy is going to be there. If you see this, this is about the policy as well. When it is performing, it is invoking the tool, and it is now, because it is invoking the external tool, it is checking the whether I'm not allowed or allowed in terms of there. And this is the policy which is there, get all S3 matrices. So this GitHub, so it's the same GitHub, three different branches that I have taken in there to perform that. Yeah, I'll put the link in there. That's about I want to present for the Bedrock Agent Core. I hope I am finished on time. I don't know. I think I've taken something extra. Yeah, um, open to questions. I'm in that case.
Thank you. I think your CC, it's really great to hear from you again. Thank you so much.
Thank
Yes,
you.
yes, it's very, very hot topics, right? So, yeah, Bedrock Agent Core is such a powerful service. Yeah. So I also love how it can generate policies automatically. That's really impressive. I love it.
You.
So I feel like, yeah. I feel like Agent Core is something that will continue to grow and become more, yeah, widely above adopt. So in fact, in my company, we haven't fully use it in production yet. So we are like we really want to do more with with
Yeah,
it.
actually, that's the thing with the AI. Like people are using it, choosing it, but when it's talk about the production deployment, still
Yeah,
everybody has a second thought in terms of how they want to put in production with all the proper, what they call it as a governance or maybe a responsible AI
yeah.
before jumping too fast. So want to use it, want to explore it, but yes. It has some other, you can say, negative downside things as well if you are not properly put in all the governance or the responsible AI things in there. So yeah, so every company, every organization, every enterprise is taking that, and which I think is a correct way. Otherwise, it will we might end up in different word which we don't want to.
Yes, step by step, right?
Yeah, thank you.
Yep. Thank you. So, does anyone have any comments, question, or thoughts for Assisi?
I've seen one in the comment in the comments, which is natural language. Okay, result. So you're talking about, I think, if you are using natural language in terms of the policy, if I understand the question correctly, if it is about the policy, I am seeing good results of creating a CIDR policy using a natural language with very less hallucination in there. But yes, sometimes it hallucinate. But I would say it's not in 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 more real scenarios which I have tested that. I have not seen it. I won't call it a hallucination. I would say the prompt was not that clear. So if you know that, okay, if you are seeing it hallucinating and you just start changing the prompt, thinking that whatever you want to convey is not conveyed properly, you will find the good results. But yes, without human in the loop, if you want automatically, okay, in your pipelines, policy gets created and everything gets attached. I would say as of now, it is too early to adopt that, unless and until you have explored that much of agent core policy or any of the AI things in there to place everything in the automatic or your pipeline as part of that.
The question?
Okay, thanks, Romy. Thanks, everyone. Yeah.
Yeah, thank you. So once again, thank you so much. Yep. All right, let's move next speaker. Thank you so much. So our next speaker was supposed to be Shabir, but unfortunately, she had argument, a matter, and couldn't join us today. I'm sorry about that. So let's move to our next speaker, Charity. Sorry. Charity, are you with us? They're not? Charity. Okay, it looks like Charity might not be here. Okay. Oh. Well, it's one of those days. Thank you, your audience. Yeah, everyone. So next, Mahendra, I'm sorry for the sudden change. Mahendra, yeah, Mahendra, mic mute. Why? Oh, they what? And Mahendra, they- they're not. Ah, okay, thank you. Okay, Barusha, are you ready?
Okay, I got lucky.
Thank you so much.
I
Thank
was
you.
waiting, okay, for my turn, luckily.
And
Okay.
please feel free to take a bit more time if you'd like.
No, 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 I'm happy.
Thank you so much.
All right. Shall I share my screen?
Yeah, thank you so much.
Not at all.
Yep. Now, next, yes, anchor. Yes, change. Yes, here you go. Thank you.
Just give me a sec. I was just going through my slides, so. Okay.
Okay,
My screen is perfectly visible.
perfect.
All right. Okay, so hello everyone. Today we're gonna talk about like how we can build zero trust on AWS. Before that, a little introduction about me. So I'm infra transformation specialist at Accenture. I'm leading cloud and operations team over there. I'm also a community builder and also multi-cloud certified. I love writing blogs. They are quite lengthy. So if you like the space, cloud DevOps and all, so you can check out my blogs. I'm also very, very much active on LinkedIn. So yeah, anytime if you have any doubt after this session as well, I'll be happy to connect with you, all of you. All right, so these topics are like not specific to any tool or something, but it's an overall approach, like how we're gonna secure our infrastructure where we are already working on it. So before we start diving into zero trust, I would like to also touch base upon the traditional approach, like how it used to be earlier when all of these things were not there. Like before COVID, I do remember we used to go to office 5 days a week, and we used to work from there. And working from office is like you're already inside a secure network. That is your office network. You're using VPN and all of those stuffs. But the COVID changed the landscape of how we used to work earlier, right? Now we are working from home remotely from anywhere in the world. So this also take us to the phishing approach or the compromise of credentials. Any attacks can happen. All of these things coming into picture because the hard outer shell, that is cloud, it's not just only you're logging in and you're working, right? Because a lot of things also comes along with that. But firstly, why network parameter fails in the cloud? Obviously, because we are working remotely, users access anywhere from the world. The VPNs create false security and poor user experiences. The cloud native reality, like the resource spans between regions, accounts, SaaS platforms, it's like no single insight exists anymore. Also, microservices chaos, service to service communication, like across traditional boundaries. The flat network exposes everything, right? So we do need something to overcome from all of these point of failures. This is a comparison, like how our traditional VPN security used to work earlier and now how zero trust security model will come into picture. Think of it as a castle and moat. Like there is a castle, all of the huge walls, and you have to enter inside the castle, right? So there will be one security gate. If you are allowed to enter, uh, obviously because you're authenticated, then you will enter and you're now inside the castle. So it's a network based trust. They trusted you and now you're inside the network. But are we here really safe? Like, what if any malicious person or who don't have any good intention, they wants to steal our credentials, important files? And come on, we are in this era, like it's all based upon data. What if one compromise happen? Like the malicious person is already entered, right? So here, once you're inside the castle, they can move in any direction and steal anything they want to. So that's where we need the zero trust security, where even though if you have entered the castle, it needs to verify again and again. Why? Because this is the one best line of zero trust security, that is never trust and always verify. You shouldn't trust the person once who has entered your premise. You should always verify after a certain point of time to make it worth, like whether the person who has entered is still relevant to stay in your network or not. Okay, so you heard a lot about zero trust, but firstly you need to understand what zero trust isn't. It's not a product, it's not a technology, and it's not a protocol. Because people, when they heard this term zero trust, they understand all of the misconceptions. So, yeah, now we know what zero trust isn't. But okay, what zero trust is? It's a conceptual model. Again, I'm saying it is not based upon any particular tool that you have integrated in your infrastructure model and you're good to go. No, it's a practice. It's a security model, and it is associated with a set of mechanism that focuses on providing security controls. And it fundamentally depends upon the traditional network controls and network perimeters. Again, we have to move from the implicit trust based on network location to the continuous verification based on the identity and context. whatever we are learning in anything, there always be a principle, right? So just we have to focus on those principles and we are good to go. So in zero trust as well, there are three main principles. First one is never trust, always verify. In this one, you will be eliminating the implicit trust that is already there, because every user, device, or application, they have to prove their identity that they are still relevant to be inside the network, or the security posture continuously regardless of their location. Second one is the implementation of least privilege access. Every time this has been emphasized, be it kind of a network, be it kind of a security, always grant minimal access that is required to perform the specific task. Because let's be very honest, in case any new person is joining your project, right? You then and there you don't provide them all of the access, like admin access, for the few period of time, like let's say for a month, you will provide them read access, because you don't want the accidental deletion or anything that happened because the other person has not proper information what to perform. So in that case, you have to limit the scope, duration, and permission to reduce the blast radius of the potential breaches. Then of course, after, if they really need the access, write access or admin access, then only provide it. But first, start with small. Third one is the assume breach, because we are in this generation, like before anything happens, we always think of the negative things, right? So again, the same goes to the zero trust principle as well. Like assume everything is already compromised, everything is already breached. In that case, what you will do, like you have to design your architecture expecting the attackers has already been inside. So in that way, you will think of the things that, okay, once the things are compromised, once the attacker has already entered, what things I could do to make my network overall secure, even after they have entered inside. Right? In that case, you can create the segmentation. Let's say this is a big chunk or a traditional castle and moat model. Once the person is inside the castle, obviously if there are segmentation happening, like let's say there are different corridors, different rooms, and again to enter those rooms or corridors, he again need to verify himself. In that way, what we did is, he is already inside the network, but he don't have access to enter into those segments or corridors. In that way, he won't be able to do any malicious activity, or he won't be able to access all of our data, right? Second thing will be encryption of data, because let's be very honest, if you're not protecting your data, again, you will be in a very bad position. Thirdly, again, everything we have put in, we have applied the roles, policies, all of those things. But what if we are not monitoring it at the first place? So again, monitoring everything, what to contain the damage and what we can do. Like, let's say anything is already inside your network and we might suspect it to be a suspicious one. So in that way, either we can block their IP address, we can blacklist those URLs, etc. So these are the principal forms of the foundation of modern cloud security. When we are implementing them correctly, be it in any order, but these principles have been implemented correctly, they create a defense in depth and protect against both external attacks, and even if the attacker is inside also it is secure. I took an example of VPN earlier when I was explaining you about the castle and moat model. So earlier, what used to happen is, suppose you are connecting to VPN, right? So VPN grants network access. Once you are inside, the trust is implicit. And it is also a coarse-grained control. That is, it's not particular about which segment you have to go. If you're inside the network, that means you can access anything. But that is not a good approach, right? So zero trust model help us enabling the fine-grained policies. Fine-grained policies as in, okay, you are inside the network, but again, what things you can access or you cannot access, again, can be controlled. So those are really called as fine-grained policies. So in zero trust model, like identity-based access to the specific resource is provided with continuous verification. So from traditional model to zero trust model, that means we are shifting from are you on the right network to who you are, what do you need, or should you have it right now or not. So understanding the question, like earlier it used to be a broad question, coarse grained control, now it will be a very fine grained control. This, like who are you, what you need, should you have it right now or not. So all of these things are continuously verified, then only you are authorized person to enter into the environment and access whatever you want to. Now we talked about the pillars, what and all things we have to keep in mind, what is VPN from traditional model to the zero trust approach, but how it works. I have talked a lot about authentication, authorization, but let's segregate them one by one. So the verification cycle in zero trust is divided into three categories. First one is authenticate. So every access request, when it comes, it passes through the continuous validation of authentication, authorization, and access. Because they all three work together, and then only the system will get to know, okay, the person is the right person to enter into our infra, and then there will be no trusted sessions that they last infinity. So in authenticate, they are verifying whether the identity using strong multi-factor authentication. All right, you're using your username, password, but again, what extra you are doing to make that layer more secure? MFAs. We are getting OTPs, like for every order we are placing or any new site we are entering, we are getting OTPs, right? So those are adding extra layer of security. All right, so you entered the infrastructure, you entered any environment, you're authenticated. Now, second, authorize. What level of access you have will define whether you can perform any action, or you have the read access, or you don't see anything at all. Because if we are enforcing least privilege access, then obviously whatever things you have to do, until then you can be there into an environment. Other tasks you won't be able to perform. So this is also a best way to restrict a person to perform the things which are not under their scope, or that shouldn't they have been visible for. Third part, all right, if you have been authorized, then you come into the SS section. In that, there will be a continuous monitoring behavior and adaptation of the security posture. Like continuously, it will be assessing you based upon these three verification cycles. So again, this cycle won't be a single time process. The cycle repeat itself for every access attempt. There are no trusted sessions that last infinity. Like once you are already entering in the environment, you have connected to it. It's not limited until that part. It will assess you continuously after every certain point of time to make sure you are the correct person inside the network. All right, we now moving to the how we can build that into AWS, because we heard a lot, all of the theoretical knowledge, but how we can implement it. So here are a few things that you can do to make your system zero trust. Firstly is IAM and identity center. So obviously identity first SS will be like SSO, single sign-on model, where a centralized user management and temporary credentials are only provided. Think of it like you don't really log in into any new site, but you use your another ID, your let's say your company's ID or any particular IP to ID to do the single sign-on. That means you don't have to explicitly create an account. It will be on a temporary basis. Second will be micro segmentation. You are dividing, you are segmenting all of the things, all of the infrastructure, so that it won't be a single chunk model. It will be divided into section to provide more security, like VPC, security groups, NACLs, private links, to isolate, to basically isolate the workloads and the traffic control flows. Like the security groups will be based upon the resources, and NACLs will be based upon on the subnet model, like what you want to allow and what you don't. Then comes the data encryption model, we want to keep our data really secure. In that way, you have to encrypt it. So for those in AWS, you can use KMS. It can be at rest, it can be in transit, depends, right? So data level zero trust control can be done via data encryption. Fourth, identity as parameter. Network location is irrelevant because nowadays everyone is working remotely, or they don't have to be on the exact company's building to work, right? They use VPN. So network locations are irrelevant, but the identity and context determine the access, whether you are the correct person or not. Fifth one is least privilege policy. This is very important. Again, you don't have to provide all of the access at the same time. Start with small, start and then build in case the person really needs a little bit more access than just a simple one. Then obviously you can add it up. So in this one, you can use IAM policies, SCP, secure control policies, permission boundaries, and then you can deny everything by default and grant explicitly what and where it is needed. Sixth one is application security, like WAFs, Web Access Firewall, Shield, API Gateway, all of these authorizers. They will verify requests at the application level as well. Now, my most important, most favorite, continuous monitoring. All right, you are inside the network, but what if we are not doing it continuously, right? So CloudTrail provides logs, security duty, security hub. All of these things provide a real-time threat and detection, and accordingly to the compliance, it will be telling us what is going wrong. We have logs, we have real-time logs, and we can obviously go down to the logs and get all of the details what is needed, right? Last one is never trust, always verify. Like there shouldn't be any implicit trust based on the network location. Every request should be authenticated and authorized, then only it will be assessed. So again, there are some reference architectures in Zero Trust that you can amplify, like for the users, when they want to access to any application, they can use Identity Center, or they can authenticate via SSO. IAM roles, which can assume whether the session policy, whatever until that time it could be. You can access granted to the API gateway endpoint, firewall validation requests, and Lambda execute with the minimum IAM permissions. So all of these things are just an example how you can integrate. Again, if your connection is like service to service, like service A uses IAM role to call service B, in that case, you can also use the security group restriction traffic to specific port. NACLs are for specific CIDRs. Private link ensures private connectivity, and every call logged in the CloudTrail, again for the monitoring purpose. Then we have CI/CD if it is over our infrastructure. So for that, we can use OIDC to assume the AWS role. It is time-bound credential with the deployment permissions only. And if you are using Terraform, then the same thing can be used. So all of these actions are audited. So in that way, you are secure. These are some of the common pitfalls and anti-patterns that you have to keep in mind, even if you are already implemented these zero trust models. Still, you need to do these checkups regularly to keep everything secured. So network only zero trust, implementing microsegmentation, but ignoring IAM. Network control alone aren't enough, so identity must be a primary thing. Admin role overuse. Again, don't grant admin access to everyone. Just start small and then you can build everything on top of it. Misconfigured policy. So these are some of the loopholes that could be there in case the person, if they wants to enter, cracks this misconfiguration, they can easily enter inside, right? So again, this could be the wildcard resources. Instead of giving access to the particular resource, you're just adding an asterisk. So asterisk is small, but the impact is big. Some of the missing conditions, overly use of broad actions or use of IAM access analyzer to catch off all of these misconfigured loopholes. Lack of visibility. Zero trust without logging is secure threater. So for that, you have to enable the visibility like monitoring, CloudTrail, Guard Duty, Security Hub from day one, because you don't want to end up in a situation where you don't have any monitoring model and anything went wrong. So how you will get the logs? So this will be a good practice to enable all of these monitoring solutions from day one. Then there is a flat network architecture, like all of the resources you're keeping in one VPC. We just learned, right? Segmentation is important. So even if one of the resources compromised, it shouldn't be like your whole infrastructure is compromised. If you have segmented everything properly, not keeping every resource over VPC, over one VPC, you have kept it depending upon what kind of things you have segmented for that VPC, it will be a segmented one. So lateral movement is trivial, so that even if the attacker enters your VPC, all of the things won't be compromised. Shared credentials, long-lived access keys stored in a code, shared across team, never rotated. This is the bad practice. You have to rotate your access key, like AWS IAM access keys are there, right? You have to rotate them. You have to rotate your password. So that's why MFAs and OTPs, OIDC, all of these things came into picture so that the credentials won't be stored for a long time, like same credentials. It should be rotated to keep everything same. This is fun of the architecture, where how you can integrate and where you can integrate all of the zero trust core is. On the left side, you can see the source where the users, pipelines, all of those things are there. So you are on this side, right? And this side is your destination. Like you have to access any of the S3 bucket, you have to enter over any of the EC2 instance, you have to trigger any Lambda, container, anything, right? So firstly, you log in, it will authenticate via SSO, your company SSO, then it should also have MFA, multi-factor authentication. If all of these things are there, then you are first correct person. Second, it won't be a flat one, right? So it will be a series of access that you need to verify. Second one, authorization, that is least privileged access policies. Even if you entered with your SSO or MFA, if you don't have authorization, you won't be able to move forward. So that is also important. Third thing, logging and monitoring. You have to continuous verify the things or the IP or any request is coming to your destination is correct or not. If all of these three criteria matches, then only it will verify and allow you to log in. And then obviously the continuous monitoring and feedback will go hand in hand. But these criteria should be fulfilled first. So this will come as a middle picture from your left to right side. That means the user or pipelines to your destination application workloads or data. This is simple if you think of them as not of any protocol or not of any tool. Think of it as a practice. Start slow, but yeah, start building on it, enable monitoring, all of these things. Then it will be a really easy and interesting topic to implement zero trust model on your infrastructure. Okay, at last, zero trust is a strategy, not a service. With a bold line, I would like to phrase it again. Zero trust is a strategy, not a service, where we are building blocks, identity first, and enable innovation. So every request authenticated and authorized 100%, then only there won't be any assumption of the network locations. So start small, pick one workload, implement identity-based access, add monitoring, iterate again, then only zero trust is a journey at every step, improves your security posture. Last, I would like to conclude my talk with the always verify before you trust. Be it anything, start implementing it in your already created infrastructure. If you're building new, consider these things before proceeding further. You can connect with me on LinkedIn. I'm very much active over there. In case you have any doubts, this is the time to talk.
Hello,
Yes.
can you get me? Okay, thank you very much for the presentation. I got a little bit confused when you were talking about the common pitfalls and anti-patterns. So you spoke about the fact that this admin role overuse, which is maybe granting administrator access. So I just wanted to confirm, for example, if I'm working on a project, right, as the only administrator, is it a bad practice to give myself administrator access, even if I'm the only admin?
Okay, again, I would like to introduce one more thing. Like, you are the only person working in your project, right? There will be a root access, there will be an admin access, and there will be a normal access like read-only access. If you are only working, it's always idle to create a admin access, not really work everything on root. Secondly, because you are the admin access and you are the only person who is working, so it won't matter. But yeah, if there are 10 or 15 people working in your project, and giving everyone admin access won't be a good thing, right? Because unknowingly things happen, and people, even if something what's not in their scope, they might run it accidentally, or all of those things happen. So that's why it is always ideal to give others only level of access what is needed, but you or the main person or the leads can have the admin access. I hope I cleared.
Yeah, it does. Thank you.
Thank you.
Okay, does anyone have any comments or questions for Barsha? Thank So first of all, thank you so much for your flexibility. Thank you. I really appreciate. Thank you so much. Security is something we all need to think about, and there's so much to manage. That's why it's so important to keep things secure, but also simple and well managed, right? So, and thanks to this community, so we can learn from people like you. So I'm really grateful for that. Thank you so much. Thank you. Okay, right. Let's try covering Charity one more time. Charity, are you ready? Charity. Sorry.
Yeah, I am. Hi.
Oh, right. Hi.
Hi,
Oh.
everyone.
Hi.
Can you see me? Hi.
Yeah. Okay. Can you
Okay.
share your screen?
Yes, I can. Let me just do that quickly.
Yes. Thank you so much. And thank you for coming today. Thank you.
Of course, my pleasure. Just holding.
Mhm.
Okay. Have to. So can you see my screen now?
Oh, wait. Oh,
Can you see my screen?
yes, good.
Okay, great. So, hello everyone.
Okay, nice. Perfect.
Yeah. Hello everyone. My name is Charity Francis. I'm very happy to be here today. One of the reasons why I thought that this topic, AWS and me, or rather theme, AWS and me, spoke to me was because I think I have a lot to say concerning this theme, but I decided to choose to talk about how AWS helped me build my first Gen AI application. So first things first, let me introduce myself. My name is Charity Francis. I'm a cloud engineer. I'm also a cloud instructor. I am multi-cloud certified across AWS and Google. So I'm both an AWS instructor and a Google Cloud instructor. I'm also an AWS community builder. I have been working with AWS for the past 2+ years. And one important thing for me is that AWS was actually my first entry into tech. So my first introduction to tech, I did not start from scratch. I did not start from software development or software engineering or learning how to program or anything. I actually started by learning AWS. So I see AWS as the platform that gave me the ground to stand on. So it's this topic, this theme is actually very personal to me. I did not have any prior tech background. I just dove headfirst into AWS and I learned the platform, I learned everything about it. And today I am very, very passionate about AWS. So thanks to AWS, I actually got curious about AI. Of course, AI is the key topic now. Everybody's talking about AI. Everybody wants to learn AI. I've actually stood back on that a bit because I'm still quite into cloud more. But then, as a cloud engineer, I had to start thinking, these AI platforms that we use, like ChatGPT, Cursor, and so on, they are built on something, right? Something is the underlying infrastructure, something is hosting them, something is housing them. Of course, as a cloud engineer, I started thinking, how are they built? What is the architecture behind these services? What is the infrastructure powering these services? That led me to actually build my first Gen AI system. So some of the Gen AI systems that we might have interacted with, chatbots, we have ChatGPT, AI assistants. Some people even have AI agents now that they are using as their own virtual assistants or their own assistants to help them perform simple admin tasks, right? And then there's also content generation tools. Of course, ChatGPT also serves as a content generation tool. You can create images, you can create videos, you can create slides using AI now. AI is doing a lot for us, helping us to improve our lives, right? Generative AI is helping us improve our lives in so many ways. So I decided to build something with Gen AI. What happens after you have actually written your prompts? You've written your prompts to, maybe you're telling ChatGPT, I want to work on this particular slide. I need you to generate the context for me, the speaker sessions, create and generate the topic I'm going to use. Give me the idea. What actually happens? Engineering is happening in the back end. Something is hosting it, something is housing it, something is being there are tools that are actually moving parts in order to bring your answer back to you. Of course, all of this happens in milliseconds, so we do not really get to see the wheels turning in the back end. But this is something that I started wondering about as a cloud engineer. What are the services that can be behind a generative AI application? that would actually be effective enough to answer questions, to answer prompts effectively. So this led me to building this generative AI financial assistance. So this financial assistant, what it actually does is that it's based on the user's prompts, and sometimes the user can upload documents to go along with the prompts, right? It generates responses that solves the user, that actually gives the user financial advice based on their prompts. So the prompts could be something like, can include your income, your age, your status, your gender, male or female, and it can give you personalized advice about yourself. So personalized advice could be, okay, you said you are 27, a woman, you earn about $100,000 per year, and this is what you want to do. This is what you want to, you are interested in high risk, low risk, medium risk investments. You can include those kind of details, right? And if you use those details to actually give you personalized financial advice, like, okay, based on everything you have said, you can actually invest in stocks, in shares. It maybe give you specific stocks that you can invest in. Also tell you how to split your money, to save better, to invest better, to obviously spend better, so that you are not just saving and investing, you're also enjoying your money. I hope I'm still with everybody. Can't really see the platform. I'll just like reactions. Okay. I hope everybody can still hear me. Hello. Yeah, okay. Thank you, Victor. Thank you, Hiromi. All right, so I'll continue then. Hold on. All right, so what were the services that I used? So I actually used API Gateway, Lambda, Bedrock, and S3. So I basically use AWS's serverless applications to build this personalized financial application. So this application was obviously very cost effective, highly performative, automatically scalable, highly available. So I did not have to spend much. I did not have to do much, and yet I was able to get the results that I needed. This was AWS actually showing me its benefits at scale, right? So for API Gateway was used to respond to user requests. So API Gateway is basically the front end that receives the user's requests. So the user sends in a prompt. The user also has an interface on the application that asks them for documents. Documents could be their bank statements, could be more details about them, whatever documents that can help to improve their prompts, right? The user enters that documents into that application, into the front end, right? API Gateway actually receives that as a request and then sends the request to Lambda. Lambda is the serverless backend that is responsible for actually performing the functions by calling to either an S3 bucket where the documents that the user uploads is saved to, and then studying that document, and then sending all of the user's response, or rather the user's prompts, to Amazon Bedrock. Now, Amazon Bedrock actually is AWS's AI model that you can use to build your own generative AI applications. It actually responds to user prompts using years and years worth of data that AWS has used to train this model. So now it can actually serve several purposes for whatever use case you're trying to build. So Bedrock is the major AI tool here that I use to build this application. So Bedrock responds to the user's request that it has actually gotten from Lambda. Lambda sends the user's prompt to Bedrock, and Bedrock studies that users request and says, okay, this person says they are 27, if they are female, the person earns 80K per year or 100K per year, and the person wants to save more and spend less. The person has a high risk tolerance. The person has also added his bank statement here, and I can read that through from what Lambda also sends to me. And then Bedrock uses that based on how I've also configured it for better prompts generation, right? Or rather for better response generation. So Bedrock now generates a personalized response that speaks to my prompts, that speaks to my own preferences or my own use case. Someone who is 40 and has a low risk tolerance and earns less than I do will definitely have a different financial advice from Bedrock or from this application than someone else who is maybe 18 and not even any yet a student. That person will also get a different personalized financial advice. S3 is basically just the storage buckets that stores all of the documents as objects. So Lambda calls to this S3 buckets to also get more context before it sends the prompt to Bedrock. So this is the actual flow. I don't know why this is showing like this, but basically this is the user, the API gateway. The user sends a prompt, API gateway receives that prompt. Lambda then gets the prompt details from API gateway. Lambda sends that to Bedrock, and Bedrock returns a response. Now, Bedrock's response obviously goes back through Lambda, through API gateway, and then back to the user. Okay, so what surprised me with doing this, this is not the only project I've ever built on AWS. I've actually built a lot of projects on AWS, but I hadn't yet dabbled into generative AI at the time. I think this was around sometime early last year. So I hadn't really dabbled into generative AI at the time. So I thought it was going to be a lot more. Of course, it was still a lot, but I used only a few services to achieve something like that, which was a big deal to me. And I also realized that, of course, cost was a big factor to consider when building a generative AI solution. And with the generative AI solution I built, it was a very cost-effective one. It is not just to set up, it's not just to just interact with AI, but there's actually infrastructure running on it. I had to do a lot of troubleshooting before I could get it to work, which also helped me to learn a lot about these models, about Lambda, about API gateway, and so on. Of course, I had to design my prompts specifically for the best response possible. So whenever you're using a generative AI solution, the response that you get is actually a direct result of the prompts that you send in. So you want to ensure that your prompt is as articulate as possible so that you can get the best response. So no matter how wonderful the generative AI solution is, prompt matters a lot. Your prompt should be as specific as possible, should have enough context to help the Gen AI solution, Gen AI application to be able to respond in the best way possible, to be able to respond in the most detailed way possible. One thing to note is that two people can actually use the same Gen AI application and get different results. So if people are using, let me say they're using AI solution to generate images, for example, one person's prompt might be better than the other person's prompt, which will also reflect in the quality of the image that is going to be generated by that Gen AI solution. So what I learned was that I was not just building an AI application, I was designing a system around it. As a cloud engineer, I was more interested in the system around the Gen AI application, the infrastructure that powered it, the costs that it incurred, and all of those other details, architecture around that Gen AI solution more than the Gen AI application itself. So, what AWS means to me? AWS was my entry into tech, which means I am a bit partial to AWS compared to maybe other AWS, other cloud platforms. It helped me to build my first Gen AI solution, and all the other applications I've built so far. I've also built a gaming application, I've built an LMS system, etc. All of this I built on AWS. So AWS basically is my learning ground, is also my standing ground, is also my foundation. It has been a wonderful ride so far with AWS. Thank you so much for listening. So I want to ask you, what would you build with AWS plus Gen AI? Now that you know that you can build several things with AWS, now you know that you can build several types of applications, including AI applications, what solution do you think you can build with AWS? Thank you very much for listening. If you have any questions, I will be happy to answer. Thank you so much.
Yeah, thank you so much for today. So actually, I'm not new lecturer and AWS community builder. That's such a unique background, right? So yeah,
Thank you.
yeah. And I have to say, I love your glass. Nice.
Thank you. Thank you so much.
Yes, I love it. So honestly, it's hard to imagine going back to world without AI in developing. Yeah. So
Yeah.
and as you said, understanding the few the mentals is what really makes AI powerful. AI
Yeah.
can make great people even better. So, but in the end, it's people who decide for choose and for rate, right? So that's why we keep learning, and of course, it always keeps evolving as well. Yeah.
Yeah.
Yes. Thank you. So,
Thank
does
you.
anyone, yeah, thank you, have any comments, question or thoughts for her? Nothing more? Okay. Thank you so much again.
Can I say something?
Okay.
Yeah, someone is trying to say something.
Yeah, just a quick question. If you were trying to rebuild this again, how would you, what are some things that you would avoid or you would try to do to make it easier for yourself?
If I was trying to do what?
If you're trying to rebuild this Gen AI application you built just now from scratch, what are some things that you would avoid to make sure that you don't spend as much time as before?
That's a very good question, because when I was building this application, I made a lot of mistakes that made me take longer than I was supposed to take. Because in the end, it was like all these things I was doing was like going the long routes instead of just going straight forward. But that was because I did not really know. I've never built something like that before, so it was a learning phase, right? So if I have to do this again, what are the things I'm going to do in order to not make those same mistakes? First things first, I will understand the exact AWS services that I need to use to build this, right? And then I will make sure that the data I'm using to build, or rather to train the model to make it into a financial assistant, I will ensure that the data is as accurate as possible. So I will have to go through transforming that data, ensuring that the data is cleaned properly before sending them to Bedrock, so that Bedrock can now be able to learn from that data, so that it can be able to give better prompts. So that was the first thing I should have done. But actually, I went round in circles about that until I figured that, oh, I should have done this first. And the moment I did that, it kind of made the entire process a lot easier for me. Also, I would also design my my APIs more thoroughly. I would also focus on designing my APIs more thoroughly, so that whenever the user is reaching this particular interface, they know what they're coming to. It's going to make the architecture a much more streamlined architecture, rather than something that a user is confused about, or the API gateway itself is confused about sending the right request to the right Lambda function. I hope that answers your question. Thank you very much for asking that, Victor.
Yeah, no problem. Thank you.
Thank you once again. Thank you so much. Thank you. All right, let's move on to our final speakers for today. Mahendra, are you ready?
Yes, Hiromi.
Hi, good to see you again.
Hello, good to see you again. Thank you for
Thank
the
you for
opportunity
coming
again.
again. Yeah, thank you.
I will share my screen.
Yep.
Just let me know once you are able to see my screen.
Great.
Okay. So in today's session, so I will walk through about that. So recently AWS introduced the tool called AWS Security Agent. So usually they say it like that, AWS Frontier Agent. So that's a business term, but in that technical point of view, so it's mostly work on that is AWS Security Agent for that SDLC. Uh, Before that, I just want to introduce myself. So I'm Mahendran Selvakumar. I work senior cloud and DevSecOps engineer at Tata Consultancy Services, and also I work AWS Community Builder and IBM Champion, and also the AWS User Group Leader for Cloud Native. AWS User Group Leader for the Birmingham User Group, and also that AWS User Group Trichy. It's in India, and also I'm one of the AWS ambassador. So what is AWS Security Agent? So the AWS Security Agent is nothing but it's a proactively secure your applications like that when you are designing and code reviewing and deployment. So it's not only work with that AWS, it works with the multi-cloud provider like you can integrate with that AWS and also that Azure and also that GCP and also that on-prem. The thing is also AWS security agent work for the three things. One is the design security review, and another one is that code security review, and another one is that on-demand penetration testing. So when you have that AWS design security review, it will review your designs. So before you create that particular environment, particular cloud infrastructure, it will review your design security based on your industry standard and also custom requirements, because you can create your standard for your industry, correct? So for specific industry standard as well you can create. So based on that one it will review, and same like that, so you can review that code as well. So when you run that GitHub pull request and GitHub code, so it will review that GitHub as well, and not only in that GitHub, so what are the source you are using. So as of now it supports that GitHub, so we can integrate with that GitHub as well. And that on-demand penetration testing, so it will validate that testing. I mean, when it will validate, it will check the entire pen test for your environment like that OWC ASP and all a lot of exploits. So if you are running the websites or applications in your AWS cloud infrastructure, so it will validate, it will verify that penetration testing as well. And in that we can have that how the things is working, because in the things we can have that AWS management console. In that AWS management console we can able to view that AWS security agent, and that AWS security agent, so we can have that AWS security agent web app as well. So in that web app you can able to review that design review, and also you can see that penetration testing reports as well. And in that GitHub integration, so we can able to remediate that particular automatic code review, like that when you raise that PR, it automatically review your code and provide that particular recommendations, like that what is the issue, what you need to be fixed in that particular AWS security agent bot will provide that particular commands as well. So we will see that in today's demo. And in the pricing perspective, so as of now, it's pay as I said earlier, correct? It will be built only for the penetration testing, and it will be in that pay as you go meter. Because when the pen test will be running, so it will be priced around 50 $50 per task per hour, because in that case it will be in the on demand. So whenever you need, you can able to run that particular pen test. So it will be based on that application, whether it will be in that small application, it will take some amount. If you are running in that particular pen test agent in the pen test in the 24 hours, it will be cost around that $1,200. So this was recently GA, correct? So this was, so in that case, so they will AWS giving the 2 months free trial. You can able to do the check that you can able to explore that AWS security agent as well, and in that AWS security agent you can able to run the 200 pen task per hour. And apart from that, so in the design reviews and the code reviews, as of now, it doesn't have any building methodology. So as of now, we can able to do that 200 design reviews and also 1,000 code reviews in that GitHub. In the demo time, so I will show the demo. So how first I will show that how we can configure the AWS security agent, and how we can integrate with that GitHub, and how we can scan that particular code repo with that AWS security agent. So I have a AWS security, I mean AWS console. So I will go to that AWS security agent. So in that AWS security agent, so we have the option called agent space. In that agent space, you can able to configure the particular security agent. So if you click that agent space, so you can able to have the option called create first agent. So I will give that Maki security agent. So I will just give the name as the Maki security agent. And also, so if I you see here, you can able to give the tags and additional data encryption as well. So what I'm going to do, I'm just giving that create. So once I created that agent space, here you can able to see the options called one is that penetration testing, and that design review, and also that code review. So all the things we need to set up, correct? So as I said earlier, AWS have that pre-configured web app. So if you click that web app, you can able to see the options called design reviews and also the penetration tests. Because as of now, we didn't enable that pen test report, so penetration testing. In that case, we can't able to see anything in that penetration test. But in the design reviews, we can able to review the design document on architecture diagram. And for example, if you are going to create some applications in AWS, you have architecture diagram, you have some configurations, correct? So in that case, you can able to see that things. So what I'm going to do here, so I have some architecture diagram. See, for example, I'll give that he asks, just give the name, and also I'm going to upload that one of the file. See, this is the security agent review architecture diagram. So I just created that one architecture diagram for the sum of the purpose. So what I'm going to do, I'm going to start design the review. So when I click the start design, it will review that particular architecture diagram. So once it's reviewed, it provide that details. So meanwhile, I will show that. So what is that particular architecture diagram? Sorry, just see, if you see here, this is the architecture diagram. So I have that AWS EKS, and also it's configured with that Fargate node. In that Fargate node, it has that Fargate parts as well, and also that NAT gateway as well. So when user access with that EKS CTL or kubectl, so it will route to that internet gateway and access that particular EKS. So that's what I'm going to review that in AWS security agent. So it will take few minutes. So see. It's reviewing. So once it's reviewed, we can able to get that particular report as well. So if you see here, you can able to download the report. You can able to clone that result. Because in the review, it's completed, correct? So it had controlled the 10 things. See, if you see here, why it doesn't have it shows an insufficient data. So if you click that one of the things, see here it will provide that one. See, in that insufficient complaint status, so it will show that the insufficient data because that AWS EKS system, the forget bit accessible via that internet, which is clearly under the conceptual access, but provides no, it doesn't have anything configured about that logging configurations. Correct? If you see my architecture diagram, I never configured anything. I never included anything about that audit logging. So that's why it's provide that audit logging. No insufficient data. See in the remediation guidance, what it will provide, you can document whether a case control plan logging or enabled or whether the cloud trial or VPC enabled or configured. So this is what it will provide the remediation guidance. In the remediation guidance, it will give that what we need to do for that particular architecture diagram. See, if we click that particular authorization best practice, it will provide the relevant. So in the TKS cluster access via the TKCTL and kubectl, correct? But it doesn't have the authorization control structures, Kubernetes RBAC and IAM also. So it will analyze all the architecture diagram. So now I have uploaded the architecture diagram. If you uploaded that entire documentation of that process, so it will provide those things as well. Okay, so this is what the particular AWS security agent design reviews will be doing, and here you can able to have the resources as well. So once you uploaded the files, it will provide that particular things as well. So on the next thing is that, so as I said, correct. So we have that requirements, because there are some requirements in that industry standards. There are some requirements for the own organization standard. If organization standards, we can able to create the custom security requirements as well. In that managed security requirements, these are the enabled in the industry standard. So it's like that audit logging and authentication best practices and authorization and information protection and also the log protection and all privileged access. So all the things will be in the security requirements. Indeed, it will be in that global based, and also that it will be in that industry based. So if you need to add anything in your organization, for example, I am working in that fintech based organization. In that fintech based organization, I need to create some security requirements for my organization, correct? So there we can able to create that particular custom things. So for example, if I click that authorization best practices, and here I can able to give that particular security requirements name, and also that here I can able, so instead of the provide that particular things, you can able to provide that natural language. You can able to provide that remediation guidance, and so what is the complaints criteria and all the things you can able to provide. So once you given those details, you can able to configure that custom requirements. So your AWS security agent works based on these requirements. So because so you can, whether if you don't need that audit logging best practices, you can able to disable that as well. So because all the things you can able to control. So this is what the AWS security agent is working. So now what we are going to do, we will integrate that particular AWS security agent with the GitHub. Okay, see now I am going to agent space. In the agent space, you can able to see that options called code review, correct? So because when we enable that code review, it automatically review the pull requests, because if and when we raise the pull requests, it automatically secure that vulnerabilities and validate that one. So what I'm going to do, I will review that, I will enable that code review. If I enable that code review, so it should be in that registration. So I will create that new registration, and I will click that GitHub. So as of now, as of now it doesn't, I have only that GitHub. I will click that GitHub and click the next. So once I click that GitHub, it should ask that install and authorize AWS Security Agent GitHub application. So because it should be installed in our GitHub repo, I mean in GitHub organization or GitHub repos. See, if I click, if just give a minute. So because what we need to do, when we click that particular app configurations, it automatically install that applications. We can able to see that particular applications in that app section. If you see here I have that applications, correct? So here I have the Kasika Vault Trader, but the same like that. So we can able to see that applications here. If I click that install and authorize, it is automatically routed to that application page. In that application page, it will configure. So just give a minute. click that integrations and I will add that integrations and click next. So once we added that particular app, I will search them. See, okay, now I am trying to access that agent. I will try to run other way. Sorry for that one. I will try to log out my GitHub and try. I think there is no issues with that. I think issue with that GitHub, maybe GitHub will be down or something. I'm not sure about that one. Can anyone try to log in from there end? Like try to log in that GitHub from there end? Can you hear me? Can you hear me?
Yes.
It's working here. Why it's not working here?
Please share your link.
Yep.
URL.
I will. Sorry.
Could you try clearing your browser cache? Maybe that will work.
Yep. I will go to that. Sorry for no, it's not working in that private window as well. I'm not sure why it's not working. I'm not sure. Maybe some issues with the GitHub, I believe. Could anyone try to log in from their repositories?
So I think GitHub is down.
Maybe because so when I'm trying to log in, it will give the error.
I couldn't log in to meetup.
Okay. Oh, my bad.
Bad is bad.
Yeah. Then no worries.
Now good time.
I didn't
Yeah, I
expect that.
think GitHub is down.
Sorry?
Because, GitHub is down. When you try to log
Yeah.
in, it shows no server
Yes.
is currently available.
Yep. It's my bad. Okay, no worries. So I will explain other things.
Yes,
It's
thank you
okay.
so much.
So, yeah, in that integration, so once you enable that agent code, so in that GitHub you can able to configure that your configuration. So once you enable that particular agent, so what it will be, it will analyze that entire things. I will show the other things because I have other repository. I think that's also I need that. Sign, okay. Because the particular agent, how the agent will be working, agent only scan that private repository, not that public repository. Okay. So when you have that private repository, it will work based on that one. So I have some private repository. Once I have the private repository, it will integrate with that users, and also it will integrate with that application as well. When you have that application, it automatically review that particular GitHub code. In that GitHub code, it will provide that output as well. It will come add the commands, and it will provide that what are the fixes we need to add, what are the fixes we need to in that commands. So all the things it will be provided in that GitHub pull request. So this is what happening in that AWS security agent. So once you enable that particular AWS security agent, you can able to monitor your pull request. So because in that pull request, it will if you raise the pull request, it will give that all the values. And when you run that penetration testing, so when you enable that penetration testing, so you need to add that particular your website domain or Route 53 domain details. Once you add the domain details, you can able to configure that particular resources. So based on that resources, it will analyze that particular penetration testing and upload that penetration testing report in that web app. So that's all on. So if you are configuring that AWS security, you need to remember these things because that in that SDLC security across in that full SDLC, correct? In that one agent, we can able to do all things like that. We can validate the design, we can validate the code, and also we can able to do the pen test because in that same context length, so we can able to configure all the things, and also that we can able to verify validate that PR as well because when user developer stay in that the same flow, we can able to land the particular same PR commands. So when they raise that PR, they can able to see that values as well. And this is it. And in that penetration testing, so we can able to do that in continuous. We can't able to do that in usually the organizations we will do in that quarterly and yearly based, correct? We don't need to do that like that. So because in then the things we can able to do with that $50 per task, I mean task per hour and on demand and multi-cloud and all the things we can able to do with that uh, fantasy. That's all. So if you have any questions or anything, you can reach me on LinkedIn. If we are not connected in LinkedIn, I'm happy to connect with you in LinkedIn. So I'm active on LinkedIn and I have write blog in my websites like called devopsonit.com and all. I usually speak in that multiple AWS Summit, AWS group and also the Hasika and other things. Sorry for that. Sorry for that trouble because I'm not sure whether that GitHub was down or not. So because in that case, I can't able to provide a full demo. So because I thought to provide that full demo with that upload that vulnerability code to that GitHub repo. Once uploaded that code in that GitHub repo, the particular security agent will be review that. So once I written, I thought to write the blog in that one. So once I write the blog, so I will share that with you in that particular community group as well. Thank you all. So anybody have any questions?
So looks two question on Zoom chat.
Okay, sorry, I will see that one.
Yeah.
Okay, sorry. So that AWS security agent, no, there is no compliance violence for using security agents because you can able to identify and proactively monitor that particular agent, correct? It will analyze it and it will proactively block that security things. So that's in that case, it's not the security violence. And also that other questions, the security agent support. Yeah, the security agent supports AWS well architecture as well, and also that security complaints support as well. Because why I'm saying, because that's what I said. So there is two requirements. One is that AWS industry requirements, and another one is that customized requirement. In the customized requirements, you can able to configure your organization based requirements. So when you configure that organization based requirements, you can able to do that as well. Any other question? Sorry, still GitHub not
Yeah,
up.
same, not me too.
I think someone
Okay.
said I am logged in. It works. Why it's not works for me? No, still it's not working. Okay.
Yes.
Thank you everyone. Thanks for the opportunity. Thank you again, once again, Hiromi. So thanks for giving that opportunity, and thanks for running that community things.
Yeah, thank you so much again for today. So, that was a really hot topics, right? So, but it looks like GitHub was taking nap day. Nap day.
It's not my day.
Yeah. Yeah. Thank you. Thank you so much. All right, let's move on to our closing. So before we wrap up, thank you so much. Let's give a big thank you to all of our speakers as we come to the end of today's session. I just want to say thank you. So I'm really grateful that we could spend this time together, and to everyone who stayed until the end, thank you so much for being here. To our speakers, thank you for sharing your experience and perspectives with us. So your takes made today truly meaningful. So we heard so many different stories and ideas from a variety of backgrounds and viewpoints. Yep. So that diversity is what makes this community so special. So moments like this remind me why we started this community in the first place. And before we close, please feel free to share your social links in the chat so we can stay connected and beyond today. If you enjoyed this meetup, I'd really appreciate it if you shared it with your AWS friends as well. Okay, so every new connection helps this community now. So and if you are interested in speaking, please don't so shy to reach out. So I'd really love to hear from you, please. So whether it's your first time or you have spoken before, you are very welcome. Yes, let's keep learning, sharing, and growing together. Thank you. So I'm really looking forward to seeing you again next time. So have a wonderful rest of your day. So Mahendra,
Thank you everyone. Thanks for
yeah,
joining.
you try. You tried. Okay, finish.
Yep, now GitHub is working.
Okay. Okay. Thank you so much.
Thank
So
you so much.
bye for now. Yeah, thank you next time. Thank you. Have a good day. Thank you so much.
Thank you.
Bye
Bye-bye.
for now. Thank you. Next
Thank
time.
you.